Hi guys, this is the Innovative Minds tutor, Mr. Richard. So in this video, we are going to work with more examples on simplification of sets. Actually, this is part 2 of our video, right? Just as promised that we will have part 2 of sets, right? The first question is 2 root 2 plus root 3 and 2 root 2 minus 3. Right, if you're new to this channel, what are you waiting for? Let's do the right thing. Let's subscribe. Let's grow the community. Yes, let's begin our lesson without wasting time. Guys, this type of expression reminds us of a difference of two squares. Why I say so? This is the same as having x minus y as well as x plus y, where when you simplify this, we are going to have x squared minus y squared, right? Then let's start with this. We'll do the same thing following this technique, right? We will say 2 root 2 multiplied by 2 root 2, but we will square it. 2 root 2 squared, right? Then you'll multiply the last terms. The last term, it's gonna be, yes, the sign here will be negative. We are going to have root 3 squared, right? Okay. Or you can use a FOIL method if this technique sounds tedious to you, right? Then when we square 4 here, when you square 2, we are going to get 4. But when you square root 2, the root and the 2 will cancel. So in other words, we are going to be left with 4 times 2 actually, which is 8, right? Okay, as well as we are going to square this. When we square root 3, it's going to be minus 3. Okay, then what is 8 minus 3? 8 minus 3 is the same as 5. So that's the solution, right? First thing first, you must see that this is a difference of two squares. If they are not the same, what if here it was maybe root 7? You're allowed to use a FOIL method. Yes, you can use a FOIL method, or what we call a distributive property. Remember, guys, algebra, it's a matter of mathematics. So we are going to the second example. Right, the second example, we are given 3 root 3 minus root 8 squared. Okay, when it's like this, it means you are going to repeat what is inside the bracket twice. Or another technique will be, yes, you can say root 3 root 3 minus root 8. You repeat again, 3 root 3 minus root 8. You can do that. Or you could say you can square the first, right? When we square 3, we know that will be 9. And when you square 3 here, when you square root 3, that will be 3. Then 9 times 3, that's 27. Okay, so let's work out. These two will multiply everything that is inside the brackets. So what is 2? What is 2 multiplied by root 3? 3 root 3 times negative 8. Let's see. Yes, 2 times 3 root 3, it's the same as 6 root 3. Then if we multiply 3 multiplied by root 8, we get actually we are going to have 6 root 24. Yes, 6 root 24. Then you square the last term there, that will be minus 8. Okay, when you yes, we are going to have minus 8. Yeah, I feel like there's something that I made a mistake. Oh, when we are squaring a negative number, it should be a positive number. That's what we are having there. Okay, so right, so from here we could say 27 plus 8. What are we having? We are having 35. 27 plus 8, we are having 35. So it's going to be 35 minus 6 root 24. So that's how you can work out with number 2. That's how you can work out number 2. Yeah, some may use a FOIL method or distributive, but still you're gonna get the same answer, right? So let's go to the third question. The 3 root 64 x to the power of 6 minus 4 root 81 x to the power of 8 plus 24 x to the power of 4. First thing, guys, we are going to use what we call a root definition. Remember, when you're having n root a to the power of m, these are the laws of sets. When you want to get rid of this, you are going to say a, and remember that this becomes a numerator and this becomes a denominator, so that we get rid of n root them. So we are going to have m a to the power of m all over n, right? So it's the same technique that will work here. So we are going to have 664 x to the power of 6, having, remember that it's the same as having invisible 1 here. So we are going to have 1 over 3. Similar case, we're going to do the same thing, 81 x to the power of 8. So we're going to have 1 over 4. So here, remember square root, when you take out the square root, oh, sorry, here it was 25. Sorry guys, I made a mistake. It should be root 25 here. Yes, my equation should be root 25, not 24. So in this case, to make things simpler, we can we take out the square root using half. So we're going to have 25 x to the power of 4. So it's going to be half. All right. So to make life easier, guys, is to now we can change everything that is inside the bracket into an exponential form so that we can apply the laws of exponents. Let's do it now. As for 64, it will be, when you change it to exponential form, it will be 2 to the power of 6, x to the power of 6 there, and 1/3. Similar approach here, we are going to have 3 all over 4. X to the power of 8, 1 over 4. Then we change its power here, it's powered. So similar case here, we're going to have 5 to the power of 2, x all over 4 and a half, powered by half. Then using our law of exponent that says an exponent multiplies the power, so we are going to have something m times n. You're going to use this law, right? It's important to also know the laws of exponents that are still applicable. So we are having 6 multiplied by 1/3, as well as 6 multiplied by 1/3, right? Okay, similar on the second bracket, we're going to do the same thing. 4 multiplied by 1 over 4, as well as x to the power of 8 multiplied by 1 over 4, plus 2 multiplied by half, as well as x 4 multiplied by half, right? Well, let's continue. 6 multiplied by 1/3, that's 2, because 6 times 1 is 6, and 6 divided by 3, it's 2. So we're having 2 to the power of 2. Similar here, we are going to have x to the power of 2, as well as 4 and 4, they cancel each other. We have 3 all over 1, which is the same as 3, right? 8 times divided, all right, this here we are what is it going to happen here? It's going to be x squared, because 8 times 1 is 8. How many times does 4 goes into 8? Twice. Similar here, we are going to have 5, half of 4, it's 2. So in other words, we are having 4x squared, because 2 to the power of 2 is 4, minus 3x squared, as well as plus 5x squared. Okay, that's what we are having there. Are we done yet? No. The last thing here will be collecting the like terms. 4 minus 3, we know that's gonna be 1, plus 5, that's gonna be 6. So the like terms, x squared, the like terms. So we're having 6x squared. Right, guys, let's go to our last questions. We're left with 2 questions. Right, let's look at this complex set. Simplify without using a calculator. First thing first, I think here what we should do is to split the numbers into perfect square and another number. we'll split the number into perfect squares, right? So we're having root 2 root x to the power of 8 already. 2 root 2, that's 8. Already 2 root 2, it's a surd. 2 is outside, but 8 can be split into perfect square. We know that 4 is a perfect square. 4 times 2 multiplied by x to the power of 8, right? Okay, we are done with the numerator. Let's go to the denominator now. Okay, in the denominator, what are we going to have? We are having 8 there, x to the power of 8. Let's split it to perfect square multiplied by x to the power of 8. Now it's to get rid of x to the power of 8. How do we get rid of that? When we get rid of x to the power of 8, it's the same. We're going to. It's the same as taking it. It's the same as saying x to the power of 8 half. You're taking it by square root. Then what is a half of 8? We know definitely the half of 8 should be 4. So in other words, we're having x to the power of 4 multiplied by 6, which is going to be x to the power of 4 and root 2, right? Okay, similar thing here. It's the same. What is the factor? Square root of 4. Square root of 4, that's going to be 2 multiplied by 2, that's going to be 4. When you get rid of x to the power of 8, it's going to be the similar approach that we did there. So we are going to have minus 4x to the power of 4, right? Then square root of 4 here is going to be 2. When we get rid of x to the power of 8, it's going to be x to the power of 4. Okay. As well as this square root of 2, which is root 2. Okay. Even here, I left something. Here, I left root 2. Sorry for that. So we can see that the common factor, it's root 2. So when you get rid of root 2 there, we factor out a min. So we are going to have 6x to the power of 4 minus 4x to the power of 4. Similar approach even in the denominator. Take out root 2. So we're having 2x to the power of 4. Then root 2 and root 2, they cancel each other. We are left with 6 minus 4, which is the same as 2x to the power of 4 divided by 2x to the power of 4. This and this cancels, as well as x to the power of 4 cancels, because we are going to use the laws of exponent, same basis. You subtract the exponent, which will be the same as 4 minus 4, which is 0. X to the power of 0 is the same as 1. So we are having our answer here as 1. This is the solution then, right? Then we are going to our last question. Prove that 2 root a plus 2b plus 2b that divided the other one is divided by a, the other one is divided by root a, is equals to this. Well, we will start with the easier side. The easier side will be to work out the left hand side. It will be to work out the left hand side, right? Let's work out the left hand side. All right, to work out the left hand side, we will have to look at the LCD. The LCD will be a times root a. So LCD will be a times root a. So let's put the LCD in the denominator. So we're having a root a. Then we can cross multiply. So 2 root a times times root a is the same as 2a. So we are having 2a, and a multiplied by 2b, it's the same as having 2ab. Right. Okay. So what we could do here is to take out the common factor. We can say 2a, then we'll be left with 1 plus b, because 2a times 1 is the same as 2a, and 2a times b is the same as 2ab. Then we're having a root a there. What we can see, this and this are common, they will cancel each other. Then we're left with 2, 1 plus b divided by root a. Then the second step, we cannot have a denominator as a root, so we will multiply by root a. We will multiply by root a. So what we could do there, root a multiplied by root a, that's going to be a, and 2 times root a, it's the same as 2 root a. 1 plus b. Right. So when we are here, we can see the left hand side is similar The left hand side is similar to the right hand side. Hence, this is equals to the right hand side. Therefore, we have proven, guys. We have proven. Hope you find this video useful, and don't forget to subscribe and like and share. Right, let's grow the community. Thank you.